Okay, in today's class, we are going to see fourth unit, potential functions. Okay, which is used in the time varying field. Okay, we had already seen the potential in static electric and magnetic field. Now we are going to see this same potential in time varying field, magnetic and electric field. Okay, this is the topic we are going to see or discuss now. So this potential will be called as retarded potential. Okay, that is here for the time varying field. Okay, time varying field is nothing but for the variance of time. With respect to the time variance, you are going to see the changes in the electric field and magnetic field. Okay, this time varying field. But already we had seen the static electric field and magnetic field potential as B equal to integral of rho v by 1 4 pi epsilon r into dv. This is for static electric field. Similarly, you'll be having static magnetic field potential as A vector. Okay, so for magnetic field potential, you will be determined by using the notation V only in the chapter. But to see the differentiation between these two, we are going to use the term or notation as A. Okay, A vector equal to integral of mu J vector by 4 pi r. See the difference here, you will be having epsilon in the denominator, but here you will be having mu in the numerator. That's the difference, and then rho v here J vector. Okay, into dv. More or less, these two equations will be same. Okay, and the epsilon mu only, we have the difference. Here in the denominator, you will be using epsilon. Here you will be using mu in the numerator. Okay, so these are the potentials of electric and magnetic field. Now we are going to see the behavior of these two potential in the time varying field. Okay, so first we are going to consider B vector. So what is B vector? Magnetic flux density. Okay, so you can write the magnetic flux density using the magnetic vector potential A vector. This B vector equal to del cross H. Sorry, del cross A vector. Okay. So now we are going to combine the above relation with the expression of Faraday's law. Okay, what is Faraday's law? E vector equal to minus del V minus dou A vector by dou T. This is the Faraday's law. So from the equation 3 and 4, we are going to determine the potential V and A vector. Okay. So from the equation 3 and 4, we are going to determine B vector and E vector with the help of V and A vector. Okay. So first we have to find out the V and A vector for the time varying field. So we know the general equation for the electric and magnetic field with the time varying condition, that is D vector equal to epsilon E vector. What is D vector? It is nothing but electric flux density. Electric flux density equal to epsilon E vector. E vector electric field intensity. Okay. And then del dot D vector equal to rho v. These two are general equations for electric field. Okay, time varying electric field. So by taking divergence of equation 4, what is divergence? Divergence is nothing but del dot. Okay, so you are going to take the divergence for the equation 4 means del dot E vector. Okay, so del dot E vector. So in that, what will happen? How we will be finding out the rho by epsilon? This is nothing but, say, look at here. This is D vector equal to epsilon E vector. Okay, so from this you can calculate E vector. What is E vector? Any idea? Are you getting? So just to replace the D vector by epsilon E vector here. Okay. So அப்ப என்ன ஆகும் del dot epsilon E vector. Okay. So அந்த epsilon இங்க போச்சுன்னா என்ன ஆகும் del dot E vector அந்த epsilon இங்க denominator கொண்டு போனீங்கன்னா rho v by epsilon ஆகுமா? So இப்ப del dot E vector equal to rho by epsilon. Okay. Have we got it? So here you are going to replace the d vector as epsilon e vector. So on the epsilon இங்க denominator கொண்டு வந்துட்டீங்கன்னா del dot e vector கிடைக்கும். That's the thing they written here directly. Then now we are going to take the del dot value for this fourth equation. Okay, so del dot t ingrappa what will happen here? Minus del square b minus dou by dou t into del dot a vector. Okay, just you are going to take the del dot for fourth equation. Okay, from this you are going to convert all the negative sign as plus and plus sign as negative. Okay, upper plus del square b. This is the right hand side equation. So this one. So minus term will become plus. Okay, upper del square b plus dou by dou t into del dot a. Okay, equal to here minus rho by epsilon. Okay, now we are going to consider the Maxwell equation. This Maxwell, one of the Maxwell equation is del cross h vector equal to j vector plus dou d vector by dou t. This is the first Maxwell equation, I think so. And then already we know the general equation. That is b vector equal to mu h, d vector equal to epsilon e vector, and b vector equal to del cross a vector. This is the general equation for the magnetic field and electric field. So b vector is magnetic flux density, h vector is magnetic field intensity, d vector electric flux density, e vector electric field intensity. Same. So a vector is in a magnetic potential. So already we know the equations. From this, we are going to write the equation del cross h as 1 by mu del cross a. The h vector clear. So what is h vector here? B vector equal to mu h. So h vector na b vector by mu. Okay, h vector equal to b vector by mu. Replace that here. Okay, instead of h vector, you replace b vector by mu. Okay, so b vector by mu. Abdada inge vandhattu del cross b vector by mu. What is b vector? Del cross a vector. So instead of b vector, replace the del cross a vector. So in the equation, h vector replace pannina, you will be getting 1 by mu del cross a vector. Purida in the first equation, in the last equation, inge substitute pannum h vector la. H vector ku badila b vector by mu. So instead of b vector, you have to replace the del cross a vector. So replace pannina, you will be getting this left hand side. Okay, equal to j vector plus dou d vector by dou t. Okay. So inge dou d vector ku badila epsilon e vector nu replace pandra. That is epsilon e vector in the right hand side. Okay. And then here mu, bring the mu to the numerator in the right hand side. That means del cross a vector equal to mu j vector plus epsilon mu into dou by dou t. What is v vector? What is v vector? From where you are writing this v vector? Here. E vector equal to minus del v vector minus dou a vector by dou t. From the fourth equation, you are replacing the e vector here. Okay. And then del cross a vector equal to mu j vector. Okay. So bring this minus sign to the outside. So what will happen? Minus mu epsilon del. Bring the del also outside. Now you make it the dou v by dou t in the bracket. Okay. The next term. So in the equation apply ஆகும். So x minus plus into minus minus only. So mu epsilon dou by dou t இங்க இருக்கு. Here also you are having one more dou by dou t. So dou by dou t will give dou square by dou t square into a vector. Okay. If this is sixth equation, and then but from vector identity, I think identity you know that is property. Okay, del cross a vector equal to del into del dot a vector minus del square a vector. Okay, So use this property here. So now replace, instead of this, you replace this property, del into del dot a vector minus del square a vector equal to, as it is, you write this 6 degrees. So yeah. The next step, now you convert all the minus sign into plus and plus into minus. Then what will happen? This minus plus sign will become minus. So minus del dot a vector. So in the minus sign will become plus. So plus del square a vector equal to, adhe mari right hand side you convert all the minus sign into plus, plus into minus. Okay. So in converting plus into minus, minus into plus, there will not be any change. Okay. The same answer will be getting. So minus mu j vector. So minus will become plus mu epsilon del dou v by dou t. So minus will become plus. So mu epsilon dou square a vector by dou t square. And then note here the fifth and seventh equation. This fifth and seventh equation will not be sufficient to calculate the a vector and v value. That is potential of both electric and magnetic field. So that we are going to take the curl of a vector. Okay, curl of a vector. What is curl of a vector? Curl is nothing but del dot. Okay, already we know the the curl vector, that is del cross a vector. Curl nave del cross a. Del cross a ஏற்கனவே calculate பண்ணிருக்கோம். எங்க calculate பண்ணிருக்கோம்? இங்க del cross a equal to b vector. So already we know the del cross a vector. So we don't know the divergence of a vector. This divergence na del dot a. So del dot a inga calculate பண்ணலாம். By using equation 7, you can get the del dot a. Del dot a bar. So compare these two sides. So where you will be getting that del dot a. So del into del dot a inga del the del. Okay. Upper the remaining terms which is added to this del will give the del dot a vector. So del dot a vector equal to mu epsilon dou v by dou t. Okay. Will give the del dot a vector. Have you understood? Here minus, but here this side plus. This side plus edutha, this side minus aidum. Adha inga kudukuram. So if you take plus here, then it will become minus here. Okay. So del dot a vector equal to minus mu epsilon dou v vector dou v by dou t. Okay. By comparing the equations on left hand side and right hand side. Okay. So here the equation 8 will give the relationship between the two potential, that is magnetic and electric field potential A vector and B vector, which will be called as the Lorentz conditions for potential. Okay. Now we are going to the same Lorentz condition in equation 5 also. What is equation 5? Del square B plus dou by dou t into del dot A vector equal to minus rho by epsilon. So fifth equation is del square b plus dou by dou t into del dot a vector equal to minus rho v by epsilon. Okay. அதே எடுத்துக்கோங்க. So அதை எடுத்துட்டு என்ன பண்றீங்க? இதுல del dot a vector substitute பண்ணு. What is del dot a vector? In the vector value of pay substitute பண்ணு இந்த இடத்துல. Okay. Substitute பண்ணா you will be getting this value. So here dou by dou t 2 times repeated. So dou by dou t and dou by dou t will give the dou square by dou t square. Okay. So del square b minus mu epsilon into dou t square by dou t square into b equal to minus rho by epsilon. Okay.